Hi, everyone. So let's factor this algebraic expression over the integers, z. Only integer coefficients. Now, the weird thing about this expression is that we have these fractional exponents, the 1/3 here and the negative 5/3 over here. But again, the same basic principles will apply. Now, first off, a lot of students like to say, oh, can I bring in the 1/3 and just make that an x? Can I share the 1/3 onto these terms? And the answer is a big ol' no. Do not do this. Don't share. I know you're told as little kids to share. Don't share the exponent over sums or differences. You're not allowed to do that. Okay, exponents, put this in purple. Exponents do not typically distribute over sums or differences. This is related to the idea that the radicals cannot be applied to sums or differences. So basically, exponents and radicals, roots, cannot be applied term by term. So you cannot raise both these terms to the 1/3 exponent. Likewise, you cannot raise both these terms to the negative 5/3 exponent. I know it's tempting, but know what you can do and what you cannot do. You cannot share the exponent here over sums or differences. Don't apply them term by term. That's true for exponents and for radicals or roots. Now, one thing we can do is use what S word, because of the fact that we have twins here. We have x cubed plus 2 as the common base for these two powers. What technique, what S word might we want to use? In fact, you may be more clever than I am, because when I first typed these notes, I didn't realize I could do this. How about substitution? Substitution. Because when you have twins like this, when you have copies of the same base, then substitution might be a nice technique. So we can replace x cubed plus 2 by, say, u. And I'll do that in my notes. I'll revise my notes. That's one reason it's good to come to class. I revise my notes. All right. Now, first of all, we can do the substitution, and then when we factor, we have u to the 1/3 versus u to the negative 5/3. Now, what do we factor out as our GCF? Remember the old school principles. We're going to factor out the power of u this time with the least exponent. Which is the least exponent? I know it's kind of busy right now, but which is the least exponent? Is it the 1/3 or the negative 5/3? On the real number line, which exponent is least? Which is furthest to the left? It's going to be the negative 5/3. Remember, any negative number is less than any positive number. Negative 5/3 is less than 1/3. Remember, negative 1,000,000 is less than 1. Warning number 5, all negative exponents are less than all positive exponents. I know the negative 5/3 looks more impressive, but it's lesser. It's to the left. It's the least exponent here. So we're going to factor out u to the negative 5/3. So two ideas here. I'm going to apply a substitution. I'm going to substitute x cubed plus 2 with u, and I should state what my substitution is. U equals x cubed plus 2. X cubed plus 2. Not that big. All right. So u equals x cubed plus 2. In fact, I'll throw in the parentheses as well. I'm going to replace all of this with u. All right. So we're going to substitute, and we're going to factor out u to the negative 5/3, the least exponent. All right. 5/3 is the least exponent. That's our GCF. basically u to the negative 5/3. All right, so when we factor, we do what D word? We divide. When we divide powers of u here, what do we do with the exponents? When we divide powers of u, we subtract the exponents. All right, so a lot going on here. Again, I'm going to apply a substitution. So it's going to be u to the 1/3. Put this over here. It's going to be u to the 1/3 plus u to the negative 5/3. All right. Now, which do we factor out? We factor out u to the negative 5/3, the least exponent. So when we do that, we're going to get u to the negative 5/3. All right. When we factor, we do a D word. We divide. When we divide powers of u, what do we do with the exponents? We subtract them. So we start off here with u to the 1/3, right? We start off here with u to the 1/3. I'm factoring out u to the negative 5/3, so I'm dividing this guy here by u to the negative 5/3. So the quotient will be u to the, I start with the 1/3 exponent, and I subtract or take away the negative 5/3. So the 1/3 minus or take away the negative 5/3. That's my new exponent here. You should write it out. The plus sign carries over. Plus sign carries over. And then this guy, u to the negative 5/3, divided by itself is just 1. But don't forget the 1. Put the plus 1 there. All right, so cleaning this up a bit, again, I'll apply my substitution here. So we have u to the negative 5/3 times the quantity, all right, is going to be u to the 1/3 plus 5/3. When you subtract a negative number, when you subtract negative 5/3, you add positive 5/3, right? And then don't forget your plus 1. Over here in the exponent, 1/3 plus 5/3 is 6/3, or 2. So we have now u to the negative 5/3 times the quantity, u squared plus 1. And then at this point, we would substitute back. So then we would get this anyway. We'd be going back to here anyway. So the base, x cubed plus 2, all to the negative 5/3, times the quantity, x cubed plus 2, all squared, and then plus 1. So I'll go ahead and erase the u's now. So we now have this. I'll underline it. We now have that. All right. Now let's look inside here. The square of x cubed plus 2. Folks, can we share the square? To square a binomial, do we just square both terms? I hope your answer is no. Absolutely not. You do not do that. You do not share exponents like that. You do not square term by term. Let me repeat. You do not square term by term. Just like you don't apply roots or radicals term by term. You do not apply squares term by term. Remember, what is the square of a plus b? What's the square of a plus b? The square of a plus b is not a squared plus b squared. Sorry, that's wishful thinking. Don't fall into the trap of wishful thinking. The square of a plus b is not just a squared plus b squared. It's not that simple. It is not just a squared plus b squared. It is not just a squared plus b squared. It's not just this. Okay, don't miss the middle term. Don't miss the middle term. It's a squared plus what? Plus 2ab plus b squared. The square of a plus b is not a squared plus b squared. It's a squared plus 2ab plus b squared. Don't forget, for that middle term, you take twice the product of the two terms. Twice the product of the two terms. That's for your middle term here, which a lot of people miss. Don't miss the middle term. Don't miss the middle term, that 2ab term. A lot of people miss it. So then, what is the square of x cubed plus 2? Work it out. Give you 10 seconds. What's the square of x cubed plus 2? Here we go. When you square x cubed plus 2, yes, you square x cubed. And remember, x cubed, all squared. When you raise a power to a power exponent, you multiply the exponent. Twice 3 is 6. So we start with x to the sixth. Right? At the end here, yes, the square of 2 is 4. But don't miss the middle term. Don't miss the middle term. Twice the product of the two terms, the 2ab term. Twice the product of the two terms. We want twice x cubed times 2. We want twice x cubed times 2. Make this nicer. Twice x cubed times 2. That's going to be 4x cubed. 4x cubed. A lot of students miss that. Let's clean this up. 4 plus 1 is 5. We like that math. 4 plus 1 is 5. And what can we do over here? We don't want negative exponents in our final answer. How can we take care of this? Well, we can, again, 4 plus 1 is 5. That's cool. This over here, we can, I'll put this in green. This over here can roll into the denominator as x cubed plus 2 all to the positive 5/3. By the way, in your work up here, you could have rolled this down as u to the 5/3. You could have done that. But eventually, you'll get x cubed plus 2 all to the positive 5/3. And it turns out that here, we are done. So we factored this over here into this, and we have integer coefficients. All right. Now, you might be saying, well, wait. On the top, this guy is basically a QD in u. If you let u be x to the third, this thing is in quadratic form. It's a QD in u. Can we factor it? Old school. We have here a QD in u, where u is x to the third. But can we factor this thing nicely? Old school. Well, no. Not like old school, as in this times this with integer coefficients. The way I know it, if you write this as u squared plus 4u plus 5, if you do the substitution, you can work out what d word for that. What d word? You can work out the discriminant. Okay, for u squared plus 4u plus 5. You can work out the discriminant for u squared plus 4u plus 5. It turns out the discriminant is going to end up being negative. The discriminant, which is sometimes denoted by this triangle, the discriminant turns out to be negative, so you're dead as far as this kind of factoring goes, over the integers, the old school factoring. Now you might protest, wait, isn't there another way that we could factor this? Aren't there other ways we could do it? That's an excellent question, but it turns out that, well, no, the top is prime over the integers. But good question, right? How do we know it's really prime? That's a great question. Well, it turns out to be prime over the integers. We know it cannot be factored old school like this because of that whole test for factorability. Discriminant is negative. We're dead as far as this goes. So we're done. All right. So next, we're going to attack section 0.9, and we're going to slay what I call monsters next time.